Okay, so systems can have one solution, no solution, or infinitely many solutions. Okay, so what we saw last class was an example of a system that has one solution. Okay, we got one solution for it. So I'm going to show you the different types of solutions. So what do these look like? If you imagine these as lines, one solution is if the lines cross and that point that they have in common, so it's like a point that works in all the equations. That would be one solution. No solution would be something like this, like if their lines were parallel, or they didn't have anything that they had in common, right? Then there would be no solution, nothing that works in both equations at the same time. Infinitely many solutions is kind of like the whole line works, right? Say, they're not necessarily the same line, because this isn't, you can't really depict this stuff graphically, but you can imagine that there's an equation as an answer instead of just a point. So x plus y equals 4, any point that works in that would be a good solution to whatever the problem is. That would be infinitely many. So that's the type of solution. So we're going to solve one of each so I can show you what the difference is between them. Okay, so we'll go back and solve one with one solution again, all the way through. And then we'll solve one with no solution, and then one with infinitely many. 1, 2, 3.
So this one will have probably whole numbers?
Yeah. Yeah, most don't necessarily work out nice to nice whole numbers, right? Sometimes their costs will have decimals and that, but this one actually works out nice. They're just whole numbers. All whole numbers. Okay, so step one was to write it in a matrix. And what do we write? Just the coefficients. We don't put it with the right sign. So 1, 1, 1, 600. 2, minus 1, 1, 300. 3, 2, minus 1, 400. And you put that line there, and that just is sort of like the equal sign. Now, my symbols that are not a universal symbol, I put a square around something that I want to be a 1. And to make a 1, you divide the row by whatever number is in its place. Okay, and I put a circle around something I want to be a 0. Okay, so I actually use two different symbols. And to make a 0, multiply the lead 1, the one that you put in the square, by the same number with the opposite sign. And add the two rows together. And you kind of go in this order, like you make a 1 here and then zeros, and you finish that whole column. Then you make a 1 here and zeros, you finish that column, you make a 1 here and zeros, and then you can read off the answer. What's the answer to this? This would be x, y, z. So remember, this is x equals 2. Y equals 3. And z equals 5. That would be an example of one solution. Now, when we have infinitely many, you don't have this ones down the diagonal, zeros everywhere else. It won't look like that. So, but we'll get to that after this first example. Okay, so that's kind of the idea. So we want to make ones and zeros and follow this format. We go here, the 1 and then the zeros, row by row, or column by column. Okay? So we want a 1 in this top corner. Good news, it already is. When you make the 1, that's when fractions come into your question, because you have to divide by whatever's there. So when there's already a 1, that's very good. Now we want zeros underneath the 1. So in row 2, so forgetting about the last row, we'll concentrate on the first 0. Okay, so forget about this one. So really you're looking at these 2 rows. The one with the lead 1 in it, you're going to use to make a 0. So this is a 2. The 1 here needs to be a -2. Same number, opposite sign. So you would say that the operation is -2 times row 1, and then you add them together, plus row 2. So you multiply the lead 1 by the same number, opposite sign, and then add them together. And that'll give you your new row 2. Row 1 doesn't change, that just stays. Then what about this one? This is in row 3. What number is there? A 3? So what do we multiply the lead 1 by? -3. And that's in row 1, so -3 row 1 plus row 3. So we're going to do these 2 things, get our new row 2, get our new row 3, and we rewrite it. Row 1 stays the same. So usually I'd have room over here to do that, and I don't, because we want to. So maybe you have room. -2 row 1, so I multiply everything in row 1 by -2 and add row 2. Adding very, very carefully. Row 1 is not changing. Row 2, and then I'll do row 3. -3 row 1. Plus row 3. Now I'm getting my calculator out so that I don't make any mistakes. I'm just going to go to the next page so that I have room beside the right step to do the stuff. Okay, this is actually a good example because there's something we can do to avoid fractions. And that's really the only time you do it. Okay, so we made a 1 and zeros in the first column. So we're done with that column. That should never change. If it does, you've messed up. Okay, you didn't use the lead 1 to make the zeros is basically what you did wrong. Okay, so where do we go from here? We're done with column 1, we move to column 2, and we need a 1 right here. Now, to make a 1, you divide by whatever number's there. Did I make a mistake, or we're okay?
Should be 1 column 4.
Oh, thank you, thank you, thank you. Yeah, don't let me go on, because we do not want, the other one's okay? Thank you. Good. We don't want to do that, because then it messes the whole thing up. Then I'd just be showing you a good example of how to start over, because you don't, if you make a mistake in that first row, you can't really find it. I mean, you could find it, but then you'd have to carry it all through all the rest of it. It would be too hard to fix. Okay, so we want to make a 1 here. To make a 1, you divide by whatever number's there. It's a 3, so you'd have to divide that row by 3, which makes a fraction, a third, and that's fine, 1 fraction. The 900 won't be a fraction, because that'll work out nice, dividing by 3. You can, instead, to make a 1, you can switch with a row below it. So would that be better in this case? It would, because then you have a -1. To make a -1 into a 1, you just change all the signs. Divide by -1. Okay? So, to make a 1, divide by the number that's there, or switch with a row below it. Why can't we switch with the row below, above it? Because I already made the 1 up here, and then if I switch that, that 1 would now be moved, and it wouldn't be in the right place, and then we would... So you don't ever switch with a row above, always below, because we're working our way down. The lead 1 starts here, there, here. So to show a switch, we're going to say row 2 is going to switch with row 3. There. And then that will work out better. So here, row 2 is going to be minus row 2, or divide by -1 or multiply by -1. Basically switch all the signs. And I'm not changing anything else, I just did that 1. You don't need to show any work for that, because that was just done. Okay, so the lead 1 for this column is right here. So that's going to stay a 1, and we use that to make the zeros. So above it, this is row 1 we need to change, and below it is row 3 we need to change. So above it, row 1, that's a 1, so we need to multiply, always multiply the lead 1 by the same number opposite sign. So -1. So -1 times row 2 plus row 1. Row 3, it's a -3, so the lead 1 in row 2, not this one, but always the lead 1, +3. So 3 times row 2 plus row 3. Does that make sense? You don't want to use this one by mistake, because then when you add, you end up with a 1 here. You already made that into a 0. Right? You always have to use the lead 1 in that column to make the zeros. All right, so off to the side, minus row 2. We already had that same thing here, so let's write it down. Plus row 1. And then 3 row 2, so 3 times row 2. Plus row 3. So row 2 is not changing. We changed row 1 and row 3. Sort of like 9 steps. Sometimes you don't need all 9 because something's already a 1. Okay, where do we go from here? So we put a 1 and then 0, the 1 and the 0. So we go to the first non-zero number, we make it into a 1. There's no row below it, so your only choice is dividing by 11, whether that works nice or not. Doesn't matter. So row 3 is row 3 divided by 11. Works nice, so. $300. Okay, so that's the one that's staying. And then we're going to use that 1 to make the zeros. So right here, that's in row 1. That's a -3, so the 1 has to be a +3. So 3 times, what row is the 1 in? Row 3. So 3 times row 3 plus row 1. And the 4 is in row 2. It's +4, so the 1 needs to be -4. So -4 times row 3 plus row 2. So new row 1, row 2, new row 2, and row 3 we didn't change. And we're out of rows to make a 1, so we stop. So what you're actually, we're working in columns, but the lead ones, we're actually making them, trying to make 1 in each row. That's what our goal is. So they happen to be in each row and column here. But sometimes there's an extra row, but not, or an extra column, but not an extra row. If you're out of rows to make a 1 in, you stop. So we can read our solution off. What's the solution? This is x, y, z. So x equals 100, y equals 200, and z equals 300. And you can check your answer by plugging them back into the original equations. And they all work. And if I had left that mistake I made earlier on, probably none of them would have worked, because that happened in that first column. So none of them would have worked. And if none of them, if the first equation doesn't work, just start over. Check your check first. check that you didn't check it wrong, but then start over. But if the first equation and the second one work and the third one doesn't, then just look at those last steps, because sometimes your mistake, you'll be able to just see it here, and then you can fix it. Okay, so let's see what happens if there's no solution. Now, I've tried to make this one purposely obvious that there's no solution, because sometimes you can see there's no solution before you start. But most of the time you can't tell. Okay. How can you see that there's no solution here? What do you see that would indicate that this is not going to work?
Do the exact same thing.
Right. When you add up x plus y plus z, you can't get both 22 and 10, right? It's not going to work. So there's not going to be a solution that works in both of those equations. Doesn't matter if they work in the third one. It has to work in all three to be a solution. So it's not going to have a solution. So if you notice that, you could just stop. But it's never going to be that obvious, okay? So let's see what happens, though. This is the same thing's going to happen here as if it weren't obvious. But sometimes you'll see that halfway through, you'll say, oh, geez, now I've got two equations with something different on the other side halfway through. You can stop as soon as you see this happening. It doesn't always happen before you start, but it will happen at some point.
So if you mess up on one that has one solution,
Yeah, then,
you might think you're
right, right. And so on tests, so what I've done in the past on tests is either not given one that has no solution, and telling you that, or indicating, solve these three problems. Like, this is from an old test. This is called review, but I used it as review last time. Oh no, I didn't say. But it was from a test, and on the test it had these three to solve, and it said one has one solution, one has infinitely many, and one has, it didn't say which was which, but, so when you got the no solution,
you got it more than once, you're like, oh, God, that's not
right. But usually what I'll say is, like, if I don't say that, I'm not giving you one with no solution, so if you get no solution, go back and solve it. Because what happens is if you stop and you say there's no solution, there's nothing for me to mark because you didn't finish the question. Right? I mark your check, and I mark how you wrote the answer down at the end, and I can't get that if you just stop and say no solution. So I will either tell you there's one with no solution, or I don't give you one with no solution. I haven't made up the test, so I don't know which I'm doing. Right? I don't tell you which one, but if you get no solution on a test, I didn't mean for that. So you would find your mistake. Okay, but so what I'm saying is if this side is the same and that side is different, that's no solution. It doesn't always happen here at the beginning of the question, but it will, if there's no solution, it will happen at some point, because that's how you get no solution. Same equation, different answers. But I'll show you what happens if we solved it all the way through. So we'll put them in. And if you know something has no solution, you just write no solution. There's nothing really more to mark. So you could write that at this point here, but we're going to solve it. It's never going to be that obvious, so. So here's a 1 in the top corner, that's good. So we need zeros underneath. Do them in different colors. So this first one is in row 2. It's a 1, so the 1 has to be a negative 1. Negative 1 times row 1 plus row 2. And the other one's a 2, that's in row 3. It's a positive 2, so the 1, the lead 1, needs to be a negative 2. So negative 2 times row 1 plus row 3. Negative 2, row 1 plus row 3. These two always match, because you're changing and you're adding the same row, and this is always where your lead 1 is, row 1. Okay, So minus row 1, minus 1, minus 1, plus row 2, zero, 0, 0, minus 12. Minus 2, minus 2, minus 2. That's row 3. So we didn't change row 1, row 2, and row 3. Okay. So there's something in here right now where we would stop. You would never go on at this point. So what is it that we see that shows that there's no solution? Right here, we've got 0, 0, 0 equals negative 12. This says 0 equals negative 12. There's no ones there, and this is not a true statement, right? So when there's no solution, if you didn't notice before, when you get to this point, there'll be a row that's all zeros except for the right-hand side, and that's no solution. That can't be true, so no solution, and you just stop. So basically, in a matrix, you're looking for this kind of thing. 0, 0, 0, and then the number, not 0. 0 would be okay, actually, over there. You can have a whole row of zeros, so that'll be okay. But just not a number on that other side. Okay? So that's what happens when there's no solution. Nothing to check. You just hope you're right. That one was obvious because you could see it at the beginning. Okay, so set it up. And maybe we should have started a new page here. 1, 2, 5, 5. Okay, what first? 1 in the top corner. It's already a 1, that's good. 0's underneath. So this needs to be a 0. That's in row 2. So what's the step? This is a 2. Yeah, negative 2, row 1. Same number, opposite sign, plus row 2. Now, what about this one? Yeah, minus row 1 plus row 3. My advice is to write your work on the side like I am doing. Some professors just write down the answers. They do them in their head, but I just think there's so many mistakes, and then there's nothing for you to check. If you do a row in your head, like when you go back to find a mistake, because it takes sometimes a half hour to do one of these if you've made a mistake. right? And it's, I think, easier if you write it down rather than trying to do them in your head. It's up to you, but I always write mine down and then I can sort of check where I made mistakes if I need to. It's usually a sign error. So we didn't change row 1. Okay. And did I make a mistake? I don't think so. I think we're okay. So next, we have options here. So you're going to make a 1 right here. Can we divide everything in here by -5 without making any fractions? Yeah, so I would just do that. You could switch with the row below it because there is sort of a 1 there. I wouldn't bother. I would just divide because it makes the number smaller anyway to work with. If it doesn't make fractions, I wouldn't bother switching rows. So this will be row 2 divided by -5, and we're just going to rewrite the whole thing with that row divided. I don't do that work off to the side, I just divide it. 15 by 5 is 3, 2. Do you notice anything about this now? Do you notice row 2 and row 3 are the same but with opposite signs? That's okay. That's not a no solution scenario. That's an infinitely many solutions scenario. One of the lines is the same as another line. So it's kind of like 2 lines on top of each other. Okay, so that we make a 1 right here. It's already a 1. We just did that. We make a 0 above and below. So above, this is row 1. So that's a 2. So the 1 that's in the square, the lead 1, has to be a -2. So -2, row 2. That's row 1. And row 3, that's a -1, so the 1 needs to be a +1, it already is, so row 2 plus row 3. Just add them together. I sometimes don't show a step where we're just adding them together, but we will if we're in class. -2, row 2. So a row of zeros is okay. That doesn't mean anything. Just gives no information to the question. But it doesn't always happen in infinitely many solutions, but that usually does. So now normally where we would make a 1, there is a 0. You can't divide by 0, so you can't make a 1 there. Because normally you would make a 1 here, but you can't. So you stop, you're done. That's as far as you can reduce it. If you can't make a 1, you don't switch anything else to zeros. These don't need to be zeros, because there's no lead 1 there. Okay, so it's all about the 1s. If you make a 1, then you make zeros in that column, but if there's no 1, then you don't. Okay, so we can't make a 0 into a 1. You can't divide by 0. 0 over 0 is not 1. So, stop. And we write out the solution. So now this will be infinitely many solutions because we didn't get enough zeros, and I'll show you how you have to write that out. So this is x, y, z. So just write out the lines, what we have. So in the first row we have x minus z equals 1. Do you see that? We have 1x and minus z equals 1. And in the second row we have what? Y plus 3z equals 2. Okay, so there's a lot more things we can do with these reduced forms. We're just doing sort of one thing with the reduced form in this class. Let's just put a square around the lead ones. So, x had a lead 1. Do you agree? And y had a lead 1. Z had no lead 1. Do you agree with that? Okay, now normally we're not going to write that. But what we do say is that x and y are called lead variables. And z is what we would call a free variable. Okay, and it's free because it's not a lead. Okay, it's called a free variable if it has no lead 1. Okay, so when you write your solution, so this is sort of step 1 of writing the solution. Step 2 is to give any free variables a parameter. So what the heck does that mean? A parameter. So a parameter is just another letter. Okay, so we would say usually t. So we'd say z is t, and t is free to be any number. All right. So step 2 is to give it a parameter. Usually we'll go t, and then if there was two free variables, we'd go r, and then s. Those are usually parameters. It's just like a standard x, y, z is usually the variables. Parameters are usually t, r, s. And then if it's more than that, they'll go t1, t2, t3. But we're never getting bigger than 1 or 2 parameters anyway. Step 3 is to solve each equation for the lead variable and replace z with t.
What's the point of saying z equals t? Why can you just leave it like that?
I'll show you. So here's the first equation that we had from our solution. So we solve for x. Move the z over to the other side. 1 plus z. Okay. And then our second equation was what? y plus 3z equals 2. So we say y equals 2 minus 3z. Okay. And some people leave the z there. Most don't in linear algebra. They'll replace it with something else. So your solution is this. Your solution has to be x equals, y equals, z equals. Okay? So x equals 1 plus t. Z is t. Y equals 2 minus 3t. And z is t. And then you say t is any number. Although we don't usually write that, but we know that. So if we wanted a solution, one solution that works, so this is our solution. It's infinitely many, because t can be any number, and that'll work in the original equation. So you would, so this represents infinitely many solutions. Pick a value for t and plug it in to get one solution. You could do it forever, picking different values of t and getting different solutions that will work in the original equation. So for example, like if you pick t as 1 and plugged it into the 3, then you get one solution. If t equals to 100, it doesn't matter what you put. 1 plus 2, so that'll be 3. Y will be 2 minus 3 times 2. 2 minus 6, which is negative 4, and z would be 2. That would be another solution. Big T is 1, T is 2, T is 3, T is negative 5, T is 100.3. It doesn't matter what you pick. That's the infinitely many solutions. Now all of these, you do have to check at least one to make sure that you got the equation right. So you can check your answer the same way. So we had, what was our question? Okay, those were our three equations. Oh. So you could pick any of these. You don't usually write these out, you just write it in the general form, which is with the one I circled. That's the solution you're looking for. But to check it, plug in a value of t, and then try it in your original equation. So if we use this first one, x was 2, y is negative 1, and z was 1. So 2 plus 2 times negative 1 plus 5. That works.
So you can just show that it works for multiple numbers of t?
Yeah, and you don't need to, you just need to check one, and then you just assume that it's true for all, because you got it from a formula. So that's 4 plus 1 minus 5, that's 0. So what I look for is your solution, but I usually, for marks on a test, ask you to check your answer, so then I do look for a check. But, in some tests I've said, like, show me 3 different solutions. Right, so you would just plug 3 different values of t in and get 3 different sets of solutions. So the reason we don't usually leave it as z is because then you would say z equals z,